go. It is time for class. So, thought today we'd start back at that last example we were looking at last class. Here we want to integrate 1 over 2x plus 1 minus 1 dx. So, the first thing we want to identify is what our u is going to be. That's going to be our denominator here, right? So we know our u is equal to 2x minus 1. So our du dx is going to be just 2. And du is going to be 2 dx. So now we've got to figure out how we're going to get this 2 to show up inside of our integral so we can write 2 dx, right? Well, to do that, why don't we just multiply by 1? Multiplying by 1, and I have 1/2 times 2 dx. Well, we can pull that 1/2 out to get 1/2 over 1 over 2x minus 1, 2 dx. Now, by u sub, we're going to replace 2x minus 1 with u and 2 dx with du to get 1/2, well, substituting, to get 1/2 the integral of 1 over u du. But this thing, it's just going to integrate out to be 1/2 the ln of u plus a constant. So when we substitute everything back in, we're going to get 1/2 the ln of 2x minus 1 plus a constant. So again, just use substitution here, right? Comparing, same thing. They start by saying, all right, identify what your u and your du dx is going to be. They don't write it out, but we also need to identify what du is going to be, right? When we do that, we're going to multiply now by 1 to get that 2 in here. We write everything in terms of u, integrate, and then substitute back in. So all the same idea here, right? They're just using the general log rule, which is a specific case of u sub. And I'm saying let's use u sub instead. Make sense? So having said that, I think I'm going to let you all puzzle over this one for a couple seconds. See what you come up with. I'm going to give you all 2 minutes to work on that one. Sloppy ass 6. Really sucks being left-handed writing on boards. It's the natural way to write. You want to blur everything. Just erase what you just wrote. So what do we think? What's the u going to be here?
X squared plus 1.
Exactly. So u is going to be x squared plus 1. The derivative of that thing, du dx, that's going to come out to be 2x. So du is going to be 2x dx. All right, so we've got 6x, not 2x. We can pull out a factor of 3, can't we? When we do that, we're going to get 3 times 2x dx over x squared plus 1. So by u substitution now, we're going to get 3 du over u. Doing this integration, this is going to come out to be 3 times the ln of the absolute value of u, which I forgot the last time, didn't I? Forgot to write that absolute value in. But we have to have it. Plus c. So substituting our u back in, this thing is going to come out to be 3 times the ln of x squared plus 1 plus a constant c. Now, question about this. Here we have to have the absolute value of u. We've got to have it here too, right? But is that really necessary in this problem? Why not?
This x squared supposed to be positive.
Yeah, it's x squared plus 1. That's always positive. So we don't actually have to, in this case, write the absolute value. But to be precise, anytime you integrate and you get the ln of something, you should have that absolute value just for precision purposes. Does that make sense? Because if we wanted to, we could change all of this a little bit and end up with something that could be negative inside the ln here. So for that reason, we have to keep these as we go through the math. So looking at this, they do the same thing. They start off by saying, all right, u is going to be x squared plus 1. Du dx is going to be 2x then. Factoring out that 3, we get 2x dx in the numerator and x squared plus 1 in the denominator. Using substitution now, we get to 3 times the ln of the absolute value of u plus a constant. Substituting x squared plus 1 back in. Notice they drop the absolute value here. It's because, again, x squared plus 1 is always positive, so we don't need to worry with it. Make sense? Folks at home, make sense?
Yeah.
Awesome.
Yes.
Dope. So let's look at some other examples. Let's look at A to start off with. If you're looking at it and you're like, oh, hell no, don't worry. This is not actually going to be as bad as it looks at first. So in A, the first thing we're going to want to do after rewriting all of this is to break up our fraction. So we can rewrite this fraction now so that it's the integral of 3x squared over x squared plus 2x over x squared minus 1 over x squared. All of this integrated with respect to x. Well, we can simplify these terms a little bit more and apply the sum and difference rule. When we do, we're going to get the integral of 3 dx plus the integral of 2 over x dx minus the integral of 1 over x squared dx. These first two integrals, they're straightforward, right? This thing is going to come out to be 3x. This thing is going to come out to be 2 times the ln of the absolute value of x. This thing, though, we need to work on a little bit. How are we going to handle this? Can we handle it? What do we think we need to do here? Let's jump to the next slide. It's the power rule, isn't it? Because this is in terms of x squared, not of 1 over x. So here we can just apply the power rule automatically. You can rewrite it as x to the negative second power dx of course we have our constant out here too. Applying the power rule now, we're going to get 3x plus 2 times the ln the absolute value of x minus 1 over x, my mistake, plus 1 over x, plus a constant. And all I've done here is said this term here, you can apply the power rule to. So now, looking at the next problem, what are we going to do for this next problem? We've got the integral 1 over 1 plus e to the negative x dx. How are we going to handle this? Well, looking at what they've done, multiplied by 1 here. And they chose e to the x over e to the x to be their 1. It's not immediately obvious, though, is it? So what is it we're actually doing here? We're just multiplying by 1, right? So that what we get down here matches with what we have in our numerator so that we have a u and a du. Does that make sense what I mean? So what I am saying is, writing this the rest of the way out, we're going to have e to the x over e to the x plus e to the x times e to the negative x. That's going to come out to be 1, right? I have dx now. Now here we've got a u, and here we've got du dx. So setting u equal to e to the x plus 1, du dx, it's going to come out to be just e to the x. So du, it's going to come out to be e to the x dx. So now integrating all of this, putting everything in with substitution, I get du over u this is going to come out to be the ln, the absolute value of u plus a constant, substituting everything back in. This is the ln of the absolute value of e to the x plus 1, all of that plus a constant. And if we look, you do the same thing, don't they? Like I said, multiply by that 1, rewrote everything, and from here to here, we just use u sub, just like what we've done up here on the board. Now in this next case, we're going to want to use long division here. Or we can rewrite this in another way. We can go 2 ways with this problem. We can divide out using long division, or we can break our fraction up into 2 parts. Let me show you what I mean. Here we've got I'm going to show it this way. X squared plus x plus 1 over x minus 1 dx. We might be tempted here to say, all right, let's break this up like I started to say a minute ago into 2 parts. X squared plus x over x minus 1 plus 1 over x minus 1 dx. You might say, all right, we can factor out an x there. It doesn't really help us much, right? And it wouldn't help us much if we went the other way either. If we broke it up even more and said, all right, well, this thing is still equal to x squared over x minus 1 plus x over x minus 1 plus 1 over x minus 1 dx. Doesn't seem to help us much either. So the way I would start this problem here is using long division to rewrite our integrand. And that's what they've done here, is they went ahead and used long division. And when they did, what came out was x plus 2 plus 3 over x minus 1 dx. All this inside parentheses. All right, so sum of difference rule lets us break this up, right? This thing then is going to be equal to the integral of x dx. We can do that pretty quick and easy. The next term is going to be the integral of 2 dx. Again, pretty quick and easy. And now the integral of 3 over x minus 1 dx. This one might take us some time. So rewriting all of this, we're going to get 1/2 x squared plus 2x plus 3 times whatever this integral is going to come out to be, right? Plus whatever that constant is. Well, here, just dealing rather with this one integral. Let's set u equal to x minus 1. Then du dx is just 1, and du is just going to be 1 dx, right? So by substitution then, this thing's going to come out to be 3 times the integral 1 over u du. So when all is said and done, we integrate and do everything else. It's going to come out to be 3 times the ln of the absolute value of x minus 1, right? So this thing evaluates out to be 3 times the ln of x minus 1. So when we plug it back in, we get 1/2 x squared plus 2x plus 3 times the ln, the absolute value of x minus 1 plus a constant. Which is exactly what they had. Now I know I cheated here a little bit because I didn't do the long division by hand, but I think we know how to do that by now. For those who want a refresher on it, I would refer you to the algebra notes in either the textbook or on Blackboard. But for now, like I said, just thought I'd go ahead and skip that. So having said all of that, check out the next problem. Awesome. We are done with section 5.3. The very last slide of this is a mid-chapter quiz. It's meant to be a review for everything in this chapter, in this section, these 3 sections. So everything from 5.1 to 5.3 is covered in this. So if you're looking for a review, this is it. That said, for the 2 of y'all in the room and anybody at home who's looking at this, is there a problem on here you want to try really quick?
Sorry, I think the other camera isn't working.
It's not? Okay, good to know. All right. Let me fix this really quick. How about now?
Yes, it's okay now.
Awesome. Sorry about that.
It's kind of far away. Can you move it closer, please?
The closest I'm going to be able to get it is if I hold it up. But this is the last slide of the week 10 notes under chapter 3 on Blackboard.
Oh, right. Thank you.
Not a problem. So, like I said, having said that, is there a problem looking at this that any of y'all would like to go over really quick? We've got a bunch. Number 8. Number 8? Okay. So number 8 says we've got 3x squared in the numerator over x cubed plus 3, that quantity cubed, correct? Or squared? Cubed. Okay. Okay. Looking at this, if we compare it to the general power rule or the general log rule, the general log rule would be the one we want to look at. Something might jump out right away to us. Take that back, no, it is the general power rule. The first thing that would jump out at us is, hey, we've got this thing raised to a power. So it might be more obvious if we rewrite it. What we've got is x cubed plus 3 raised to the negative third power times 3x squared dx. So we've got this thing raised to a power, and the derivative of this thing sits outside, right? So this looks like u sub. Let's set u equal to x cubed plus 3. Then du dx is going to be 3x squared, and du is going to be 3x squared dx. Now by u substitution, this thing turns into the integral of u to the negative third du. You know, that is the power rule. So this thing's going to be 1 over negative 3 plus 1 times u to the negative 3 plus 1 plus a constant, right? So this is going to come out to be 1 over negative 2 u to the negative second power plus a constant. And substituting everything back in. What we're going to have is negative 1/2 x cubed plus 3 to the negative second power. So what do you think? Any other problems we want to look at on this? Folks at home, is there anything that sticks out to y'all that you're like, oh yeah, I want to look at that? Well, I'm going to assume that is a no, and say in that case, let's look at the homework. Because I don't want to put us in a spot where we're looking at new material before this exam. I'd rather us look at the homework.
There's a homework problem I specifically had a question about.
Okay.
It honestly seemed really simple, and I don't know, like, I was just overthinking it, but it was the integral of dr. I think that's, what?
Was it DX?
No, it said dr, I thought.
Okay.
It was like number 3 or 4 towards the beginning.
3 or 4. Okay, so in this example, what I've got, it changes for each student. That's the one thing that is different. So for some of y'all, this is going to look like dr, some it's going to look like dx. But what this problem is, really quickly, let me see if I can get more of the board up there. Looks like dope along that line. All right. So what we've got is something that's going to look like, well, let me write this out. Week 10, number, I think it was 4, right? Number 3, my mistake. Number 3. This is going to look something like this, right?
It's dy.
It changes for every individual. That's the one thing that changes for everyone. Some people it's dy, some people it's dt, other it'll be dr. There might even be a ds in there. But generally, this is what it's going to look like. And all we're saying here is that we're going to integrate with respect to t, or to y, or to x, or to s, whatever the variable might be. Well, this thing is equivalent to writing the integral of 1 with respect to t. Well, the integration of a constant, that's just going to end up being t times the constant, right? Plus another constant. So looking at it, it's easy for this one to get kind of lost in translation. If we're not thinking about this invisible 1 being here, it's easy to lose track of what's going on.
I knew I was overthinking that.
It's an easy one to overthink, honestly. Let me remove that pen and sharpen that a little bit. Here we go. Go. So looking at another problem then. Is there another problem maybe that any of y'all have looked at and you're like, I have no clue how to even start this?
Number 7, please.
Number 7, all right. So number 7's got a couple different things going on, it looks like. And my example that I've got up here, let me zoom in on this. So for those of y'all who haven't been in this room, there's another computer in here, and I'm looking at the problems on that. So I'm gonna have to move back and forth between the two. All right, this is number 7. We've got that dm dt is equal to 1.218 t squared minus 44.72 t plus 709.1, right? What this problem's asking us to do solve this particular equation. $19.70? Oh, no. No. Okay. So this problem tells us, let me come over here, that time 0 corresponds to $19.70. And at 2005, M of our time, whatever that particular time is, I'm just going to write it as TK for right now. Say at a particular time, M is equal to 59529. 59529. All right, so our first question is going to be, what is this TK? Well, to find TK, we're going to have to find the difference between these, where 1970 is equal to time equal at 0. Does that make sense what I mean? So if time equal to 0 corresponds to 1970, subtract 1970 off, we get to our time, right? Subtract 1970 off here, we're going to get to that next time. So TK is going to be equal to 35. So now we're going to come over here and say, all right, cool. M at 35 is equal to 59529. And we want to solve the particular equation for that. We want to find the particular solution. So what are we going to do here? Excuse me. Well, the first thing, we're going to integrate this so that we get M plus a constant, right? So M as a function of time is going to be equal to 1.218 t squared minus 44.72t plus 709.1 dt. Integrating this is going to come out to be 1.218 t cubed over 3 minus 44.72 t squared over 2 plus 709.1 t plus a constant. Now, we're going to go back and use our initial value to solve for C. So M at 35 is going to be equal to this thing, this value is constant out front, it can reduce down to 0.406 35 cubed plus, this can reduce now down to 22.36 35 squared plus 7.09.1 35 plus our constant. All this is equal to 59529. Now I'm not going to pretend to know what 35 cubed is, 35 squared is, or what these actually evaluate out to be. But what we're going to do from here is solve for C. Once we solve for C, we have our particular solution. That gives us our model for MT. So solving for C, we're going to get our model and the answer to part A. From here, to solve part B, what we want to do is find out what T corresponds to 2011 and plug that in. Does that make sense what I mean?
Plug it into the model.
Yeah.
You know.
Yep. Plug it into the model and see what it comes out to be. Does that make sense to everybody at home?
Yes,
I'm sorry, go ahead.
no, it's fine.
Awesome. I'm assuming that's a yes.
Yes.
Cool.
You use. Yeah.
So let's look at 8 really quick. Eight is another problem similar to what we just solved. We've got, zoom back in. Eight, F double primed of X is equal to X to the 3/2. F single primed at 1 is equal to 7, and F at 1 is equal to -1. So for this first problem, or for this example, the first part that we're going to have to tackle is finding out a general equation for what F prime is going to look like, right?
I think it's a negative x is to the power -3/2.
Thank you. Yes. Wasn't sure that was going to be one of the numbers they changed or not. Thank you. Yeah, WebAssign likes to have certain problems that changes their values. And it looks like any number that's red is what it's changing. So thank you. So the thing we're gonna do here is we're gonna integrate. Well, first, let me write it like this. We're gonna find a general form for our first derivative of our function. That's going to be equal to the integral of x raised to the -3/2 dx from here, excuse me, using power rule, we're going to get that this comes out to be 1/-3/2 plus 1 times x raised to the -3/2 plus 1 plus a constant. Rewriting this again. You're going to get this comes out to be -2 x to the -1/2 power plus a constant. So now we have to solve for c. Well, we know f prime at 1, which is equal to -2 times 1 raised to the -1/2 power plus c, this thing comes out to be 7. Simplifying all of this, we're going to get -2 plus c is equal to 7. Add 2 to both sides. We get c is equal to 9. All right, so f prime of x is equal to -2 times x to the -1/2 power plus 9. From here, we're going to integrate again so that we get f as a general function in a general form. So f of x is going to be equal to the integral of -2x raised to the -1/2 power plus 9 dx. Sum and difference rule lets us break this up. What we're going to get is -2 times 1/-1/2 plus 1 times x to the -1/2 plus 1 plus 9x plus a constant. Simplifying, this comes out to be -2 times 2x to the 1/2 power plus 9x constant, or just -4x to the 1/2, right? Plus 9x plus c. Now, we have to go back to our initial value. We're told that f at 1 is equal to -1. So I'm going to erase what's here for now. So I have room again. F1 is equal to negative 4, 1 raised to the 1/2 power, plus 9 times 1 plus a constant is equal to negative 1. Well, this thing, simplifying all the way through, it's going to come out to be negative 4 plus 9 plus c is equal to negative 1, or 5 plus c is equal to negative 1. Subtracting 5 from both sides, c must be equal to negative 6. So our answer then would be f of x is equal to negative 4x raised to the 1/2 power plus 9x minus 6. Everybody cool with this? Yep. This is pretty much the same idea as the last problem, just with a few more derivatives attached. So, looking at some more problems.
15.
15, yeah. Okay, so 15 here. Let me zoom in. This wants us to find the tangent line, correct?
The equation.
The equation, yeah, okay. So this is just like this problem that we just did. It's just written in a different form. So we're told in this number 15 that f of x goes through the point zero, 2/3. The 2 is going to change for some of y'all. So what this tells us is that our function at 0 has to be equal to 2/3. This is the first thing to note. Now from here, we're told that f prime of x is equal to x times the square root of 25 minus x squared. And now we know f at 0 is equal to 2/3. Step 1, find the general form for our function. F of x is going to be equal to the integral of x times square root of 25 minus x squared dx. Let's rewrite this. Rewriting it, we're going to get the integral of x times 25 minus x squared to the 1/2 power dx. All right, looking at this, we want to use u sub, right? Setting u equal to 25 minus x squared du dx is going to come out to be negative 2x. So du is going to be equal to negative 2x dx. So we need to multiply by a 1, right? When we do that, we're going to have negative 1/2 times negative 2 x times 25 minus x squared 1/2 power dx. Now we can apply u sub, right? We've got du right there with our negative 2x dx, and u inside here, right? So with u sub, we're going to get negative 1/2 the integral of u to the 1/2 du. Integrating, we're going to get negative 1/2 times 1 over 1/2 plus 1 u to the 1/2 plus 1, all plus a constant. This is going to come out to be negative 1/2 times 2 over 3 u to the 3 over 2 plus a constant, or negative 1 over 3 u to the 3 over 2 plus a constant. So when we substitute back in, we get negative 1 over 3 u to the 3/2, my mistake, negative 1 over 3 25 minus x squared to 3 over 2 plus a constant. All right, so that gives us our general function, right? So let's come back over here. Let me erase all of this now and leave this stuff here. Minus x squared, 3 over 2, plus a constant. Now we're told at 0, this thing comes out to be 2 over 3. So f at 0 is equal to negative 1 over 3 times 25 minus 0 squared, 3 over 2 plus a constant. This has to be equal to 2 over 3. While simplifying everything, Let me write this more clear. Plus c is equal to 2 over 3. Simplifying everything, we're going to get negative 1 over 3, 25, raised to the 3 over 2, plus a constant is equal to 2 over 3. Anybody know what this is? 25. It's going to come out to be negative 1 over 3 times 125 plus a constant is equal to 2 over 3. So this tells us then that C is equal to 2 over 3 plus 125 over 3. Or 127 over 3, which we can reduce down, I think. No, we can't. No, we can't. We can't. No, you can't. I take that back. I'm up here arguing with myself. So what we just found then is that the exact form of our equation f of x is going to be equal to negative 1 over 3 25 minus x squared to the 3 over 2 plus 127 over 3. Make sense? Yep. All right, let's look at another problem. Did y'all have another problem at home that you wanted to look at? It's that noise next door.
I was almost thinking it was like the wind or something, but.
I was afraid it was a side effect. Like, am I hearing things? Okay, so for this next problem, 22 looks like a good one, right? Yeah, 22 is a good one. 22 is a really good one, actually. Because it pulls a bunch of rules together all at once. All right, number 22. Number 22 asks you to integrate x 1 over x times the ln of x to the 5th power with respect to x. What are we going to do here? People at home, what do y'all think? What's the first approach here? First step.
Sorry?
What do y'all think the first step is to this problem here? It's number 22 in the homework. The first step that I would suggest is rewriting this term with a power. So we can rewrite this thing as the integral, the ln of x that thing raised to the negative fifth power times 1 over x dx. So what do we think from here? U sub? Seems like a good idea, right? Been using it a lot lately. And what we've got in here is if we set this thing equal to u, well, its derivative would be 1 over x, right? So why don't we do that? Why don't we say, set u equal to the ln of x, du dx is equal to 1 over x, and du is equal to 1 over x dx. Well, now substituting in, what we would have is u to the negative fifth power du. And this thing's going to come out to be 1 over negative 5 plus 1 times u to the negative fifth plus 1 plus a constant, or 1 over negative 4 u to the negative fourth power plus a constant. Substituting back in, we're going to get 1 over negative 4, the ln of x to the negative fourth power plus a constant. Looking at another problem. Let's see, is there any other good ones that I see? None that are jumping out at me.
25.
25?
I also have problems with 25.
All right. They're going to want you to show with C in your function because they don't give you initial data. That's why. I mean, just a second here, guys. I want to verify something. Because I can see that one. Throwing a curveball. It is. Okay. So 25, if it gives you a hiccup, I'm going to show why. Let's get back to the problem. Okay. And zoom in. All right. So for 25, if you have a problem with it, it's going to be because the way this problem is presented. So we're going to start off by assuming c is equal to 0 in 25. And I suspect this is where most people will find the problem in this problem. Pull it back up here. What we're trying to say. Okay. So this problem was poorly written, and I didn't look at it close enough, so I apologize for it being poorly written. What it tells us is that dr dx is equal to 51 minus 0.02x plus 120 over x plus 1. Find r of x. So we're going to integrate this thing, this dr dx. Say r of x is equal to the integral of 51 minus 0.02x plus 120 over x plus 1 dx. Well, luckily we can break this thing up using that sum and difference rule, right? Was it minus? Yeah, it was. Okay. Minus the integral of 0.02x x plus the integral 1 over 20 x plus 1 dx. Well, these first two integrals pretty much do themselves, right? We're going to get 51x minus 1/2 0.02 x squared plus, let's rewrite this integral here as 120 times the integral 1 over x plus 1 dx. We're going to have to apply u sub here, aren't we? So looking at just this integral for a second, we've got 120 times the integral of x plus 1 dx. I'm going to set u equal to x plus 1, then du dx is 1, and du is just 1 times dx, right? So this tells us, by substitution, this thing's going to come out to be 120 times the integral 1 over u du, which is equal to 120 times the ln, the absolute value of u. Substituting u back in, we get 120 times the ln of the absolute value of x plus 1. Okay, so now we're going to go back to what we had above. And say this whole thing comes out to be 51x minus 0.01 x squared plus 120, the ln of the absolute value of x plus 1. And we're assuming c is equal to 0 here. So our x is equal to 51x minus 0.01 x squared plus 120, the ln of the absolute value of x plus 1. Now, the rest of it asks to approximate the graph, to find the graph, using a graphing calculator or what have you. And then the rest is just plug and play with numbers. Yeah. Yeah, the rest is just plug and play with numbers. So having said that, since it is past time now, I will let y'all go. If y'all have any questions, I'll stick around for a few seconds, a few minutes.
How many questions are on the test?
Check really quick. Go back one. 8. There are 8 questions. So there's 8 questions on the exam 3 for anybody who's curious.